I wanted to do a video just on real numbers and the different types of numbers that you deal with in your algebra classes. Um, this is in section 1.3, and questions related to this are probably the hardest part of section 1.3. So I just wanted to go ahead and do a video on that you could refer back to periodically. All right, so first off, I'm using a kind of an organizational chart here. It might be similar to what you might do in a biology class when you're classifying types of animals. So if you have a box like this one that's completely contained within the next one, that means any number that I put in this interior box is also part of this number system. And because that's completely contained in the next box, those kind of numbers are also part of that number system. All right, so let me go ahead and show you what I mean. So this first box right here would be what we call the natural numbers. Okay. And so sometimes they're called counting numbers. So they're numbers like 1, 2, 3, and keeps on going on up. So just positive, nice numbers. Doesn't include 0, doesn't include negatives. Okay. All right, the next number system, I'm just going to change colors back and forth as I go out. What I would throw in with those numbers to make up the next number system is just a 0. So 0 together with 1, 2, 3 on up, that would name this next set of numbers. They're called the whole numbers. Okay, and natural numbers are completely inside the box of whole numbers, and this is just trying to show you the relationship between those two types. So 0 is a whole number, but it's not a natural number. But like 3 is a natural number, and it's also a whole number. Okay. All right, let me go back to the black one now. Now I'm going to throw some numbers in this region right in here. I'm going to throw in numbers like -1, -2, -3 on down. Okay, -4, -5, all the way on down. When I put those numbers together with 0 and 1, 2, 3 on up, I have a set of numbers we call the integers. Okay. All right, now integers is a slightly different word than using the word signed numbers. Signed numbers, they use that sometimes because you might have a positive or negative on a fractional number as well. It's just to be within the box for integers, you have to be very nice. Positive, negative, or 0, but not fractional or decimal, okay? Numbers like 1/2 would go out here. Numbers like 0.75 or -0.75, they're outside the integers, but they're still over here on this left-hand side. They're still a type of number that we would call the rational numbers. These are rational numbers. Okay, so rational numbers are going to be numbers that can be put in the form a over b, where these, the a and the b, are both integers. They don't have to be that way to start with, but that's kind of the definition for rational. So like -0.75 is the same as -3/4. Other numbers that would be in there would be numbers like -2.131313. If I have a block of digits being repeated like that, we could write it -2.13 with a bar over it, and it would equal -2 and 13 over 99. And there'd be a way to write that as an improper fraction. So I just want you to know, if you've got like a decimal that keeps going, but it repeats a block of digits like this one did, then it's actually on the rational number side. Okay. All right. Now, let me put one more fraction. So you can have fractions where maybe you have a bigger number on top. They still are rational numbers, and they would still be over there on that left-hand side. Okay, the kind of numbers that are going to be over here on the right are what we call not rational. We call them irrational numbers. And you've dealt with some of these. These are numbers that are decimals they're non-terminating, non-repeating. So they don't stop and they don't repeat decimals. Okay. Okay. When I'm doing my videos, my screen is straight up, so that's why my writing might be a little worse than normal. I have to have access to my keyboard. And so, for instance, one number you've dealt with before is the number pi, which we name that way because if we try to show you the decimal for it, we can't. We can only show you like a decimal approximation, or sometimes we use a fractional approximation. Okay, but they're just approximations. That's actually a decimal where the decimal would keep on going forever and it would never stop and never repeat. Okay. There's another one like that called E. It's Euler's number. And we use it a lot in pre-calculus. We use it as the base for some expressions we use in pre-calculus. And it is a decimal. It's also close to 3, but it's a little less than 3. Okay, and then you could have something like this that kind of looks like that negative 2.13 case, but it's not. What if I had like 4.10100100001? So you can see a pattern to it, but it's not a block of digits that's being repeated over and over again. So that's why it's over here on the irrational side. If I had 4.101, let me make sure I get it right. 010101, that I could represent as a rational number, and that would be over on the left-hand side. Okay. All right, and the way we use it a lot of times in algebra is this really comes up more than anything else when you're dealing with quadratic equations, which doesn't happen till Math 100, but it doesn't hurt looking ahead. Everything in the rational number box together with any number in the irrational number box gives you what we call a real number, okay? And these are the things that you can graph in a real number line, on a real number line, okay? Or later when you plot points in a real number coordinate system, okay? Any number on this number line, okay, if I were to put a scale on it, any spot I choose, like say I pick right there, it would have a real number matched up with it, and the real number might be nice, be a rational number, or it might be not so nice and be something like pi. But to fill up that whole entire number line, I have to have both rational and irrational numbers. Okay. Now in blue, I'm going to change this up on you a little bit and just give you the heads up that when we get into solving quadratic equations later, we expand this. Okay. We take real numbers together with what we call imaginary numbers. And real numbers being everything in both these boxes, when we put those together with the type of number called imaginary numbers, I'm going to erase this number line, okay? We get a set of numbers that are called the complex numbers, complex number system. And usually that gives you everything you need throughout all of your algebra and even your calculus classes, okay? So our focus really is on the real number system. But when we get to quadratics later, we're going to have some radicals, square roots and things that come into play. And I just want to show you where the different radicals would go. So let me keep the blue here. If we wound up having a number like square root of 16, it would actually belong in here. Because square root of 16 is really equal to 4, isn't it? So it's a natural number. Okay. All right, and then something like negative square root of 16, negative out in front, would be there because that would equal a negative 4. And you could have something like the square root of, and it could be, it doesn't have to turn out nice all the time, but it could be something like square root of 25 over 9. That would actually be out in this area called rational numbers that aren't integers, because that would equal 5 over 3 when you do the square root of both. Okay, When you have square roots and all, what puts them over here in the irrational number is when you try to do the square root of something that is not a perfect square. There is no number times itself that would be 7. If you did square root of 7 on your calculator, it would be a decimal that would just keep on going forever, so that it would belong there. And then later you'll learn that if you have something like the square root of negative 16, or like the square root of negative 7, a negative under the radical, it bumps you outside of the real number system. And those would be some examples of imaginary numbers. It's actually why you need imaginary numbers. So square root of negative 16, later you'll learn is 4i. Square root of negative 7 would just be I square root of 7. And you don't have to know that so much, but I just want you to kind of be aware there's more to it than what we need, okay? All right, so I'm going to try to, let me get some paper, additional sheets of paper. Let's just go to the homework and do a question off of the homework. So I'm going to go into my math lab assignments, and I'm going to go into that assignment on 1-3 and do the question related to this. Okay, so it'll be near the end. Let me find it. Let me just go the regular way. Sorry, give me a second to get back where I want to be. Okay, so I want to do this one. Let me just go into it like a student and just open it instead. Here we go. All right, and let's find the question I want to do. So I'm just jumping in the middle until I get to the one I want to do. I think most of the other questions in there, just reading a little bit when you look at the examples would be good enough. But the one on classifying types of numbers sometimes is difficult. Where is it? Okay, here we go. Here's an example. All right, so there's a lot to this question. So to read the directions to start with. We want to list the numbers out of this set that they gave us that are considered natural numbers. Then they want us next to list the ones which are whole numbers, then integers, then rational, then irrational, and then real. Okay, so really this question right here is only asking for the natural, but then it would come up with a part B and a part C once you get started. So let me just snip this so I can write on it, and we'll just work that question out. Okay, so let me just make my list over here. So let's say I'm trying to do natural numbers. Okay, so that's that innermost box. When you look at the scheme we had before, you got to kind of have that right next to you. So that means those are the numbers that would have been in that innermost box, numbers that would be equal to 1, 2, 3 on up, okay? Okay, so let me get back to my snip. All right, so I'm looking in that box, and it wouldn't be -5, can't have negatives, okay? It wouldn't be -3/5 or 0 or 0.2 or square root of 5 or 5.9, but you see that comma 4? Let me write these a little bigger, or let me stretch this out a little bit so you can see it better. Okay, this is the only natural number. The natural numbers would just be 4, okay? All right, now here's the tricky thing, so listen to me on this. When they ask you for whole numbers, you know how whole numbers was the box that contained natural numbers and then also 0? So you don't forget that 4 is also a whole number. Yes, it's a natural number, but it's also a whole number. So make sure you include that together with 0. So those are the whole numbers from that set. Okay, all right, the next one we did, they asked us for is integers. So this is A, this is B, this is C. So integers are still pretty nice, just positive or negative nice numbers. So -3/5 wouldn't be included. The 4 and the 0 we had before are still there, and then the -5 would be an integer. -3/5 is a signed number, but see how it's fractional? So it'd be out in that rational number area. Okay, let me move over to here. So for rational numbers, I would look for anything that could be written as a fraction. Okay, let me rewrite that real quick. All right, and the 4, the 0, and the -5, the integers is a box completely contained within the rational number box. That's trying to tell you that 4, 0, and -5 are also rational numbers. All I'd have to do is put a 1 underneath those to have them written as a fraction. But in addition to that, the number -3/5 should be included. Okay. The number 0.2 should be included, because 0.2 is the same as 2/10. And that number 5.9 would also be a rational number. Okay. And then E asks you for irrational. Here's where you don't include all the others, because see how irrational numbers is to the side of rational, so it doesn't, rational numbers are not irrational. These are rational, these are not. That's what the ear part means, not rational. So everything else, which would in this case be just the square root of 7. And then on F, for real numbers, that would be everything in this list. It would be all of them. Only thing you would know of that's not real would be if you had like an I, later you'll learn about those, or if you had a negative underneath a square root sign. So you would list all the ones you had before that were rational. Okay, so that's everything in that list. Then you would go and you'd include anything that was irrational, which is basically the whole entire list. Those would be your real numbers. Okay, so I think a lot of the other problems in section 1.3, you'll be fine, just trying to work those from my math lab with the little explanation I'll give you in class tomorrow. But the real number system problem, I think, is the one that gives people the biggest trouble. So I thought I would do a video to help you with that. Okay.